Hello viewers and my dear students, welcome back to my YouTube channel, Educational Videos at Sabir Pasha. My dear students, in our previous video, we have discussed about the rules of Cartesian sign, when to use positive and negative and how to write the nature, size and position of the image. We have discussed in our previous video. If you have not yet gone through that video, so better now you just watch that video and thereafter come back to this video. In this video, we are going to discuss about how to solve the numericals on the concept light reflection and refraction. Dear students, as we all know, if you want to solve the numerical, then we must know the formulas. If you know formulas, at least we can able to write given data and suitable formula, and thereafter substitution also we can able to do. Without formula, we can't do anything. And one thing you need to be remembered, dear students, in physics, to solve the numericals, concept is power. So you need to know the complete concept of the lens. So I hope your teachers might have taught you very clearly and you don't have any confusion. And now we try once again. Those who are having confusion, they too, let's avoid their confusion and try to get good marks in the annual examination. Numericals, light, refraction as well as reflection. Now, whichever formulas will come in this chapter, first let's list out on the board I have written. So we all know very well one formula, R is equal to 2f. It is nothing but radius of curvature is equal to twice of focal length. On the base of that also, you are having 1 or 2 1 mark numerical. In 1 mark, you may expect that question. And thereafter, most importantly, mirror formula we are having. And that mirror formula is 1 by v plus 1 by u is equal to 1 by f. Here you need to be remember, in mirror formula plus will come and in lens formula minus will come. Now 1 by v, v is nothing but image distance, u is nothing but object distance and f is nothing but focal length. You know very well that. Now let's come back. And related to mirror only, we are having magnification. Magnification of mirror formula is that m is equal to h dash by h is equal to minus v by u. Here you need to be remember, in magnification of the mirror, minus v by u. And here h dash is nothing but height of the image by height of the object. Height of the image by height of the object is equal to minus v by u. And now let's move on to lens formula. And lens formula is 1 by v minus 1 by u is equal to 1 by f. And the next magnification of lens formula is m is equal to h dash by h is equal to v by u. Here h dash is nothing but height of the image. Height of the image. Here also you remember h dash is nothing but height of the image. And here this is h. H is the height of the object. Height of the object is equal to v by u. Apart from these 5 formulas, there is one more formula is there, that is power of lens. And power of lens formula is nothing but, here I'm going to write, it is nothing but P is equal to 1 by f. It means power of a lens is the reciprocal of focal length. On the base of this also, you are going to get 1 mark or 2 marks of numerical. These are the formulas which you need to remember in this chapter. By using these formulas, and in the previous video what we have discussed, Cartesian sign rule. Now let's try to solve 1 or 2 problems. And now in this video, I'm going to put all the solved numericals, whichever is there in your textbook, including worked examples as well as textual numericals as well as exercise numericals. Numerical. Dear students, you see the problem which I have wrote on the blackboard and even which appears on the screen. See, first you need to understand the numerical very well. Thereafter only you have to choose the particular data. See here, a convex mirror used for rear view. Rear view means it is nothing but, you know very well, convex mirror. Okay, so vehicle side mirrors, rear view mirrors. On automobiles, automobile means nothing but here vehicles only. Vehicles, all vehicles together we call this automobiles. Has a radius of curvature of 3 meter. Okay, 3.00 like given. And majority of students get confused with the 3.00. It is nothing but 3 only. If a bus is located at 5 meter, 5.00 here also given. From this mirror, find the position, nature and size of the image. Now by reading that, let's pick the given data first. Okay, the foremost thing is you have to choose the data clearly. If you choose data properly, then 50% there only you got success. Okay, now given data, what and all the things it has given in the problem. Say radius of curvature. Radius of curvature R is equal to 3.00 given, but it is nothing but 3 meter. And if a bus is located at 5 meter from this mirror, it is nothing but object distance. Bus is somewhere else. Okay, that original bus is somewhere else back. And I am seeing through the mirror, in the rear view mirror. It means original object is behind me. That bus is behind me. It is nothing but object distance. U is equal to, as we have no Cartesian sign rule, So irrespective of lens and mirror, we have to use negative sign for object distance. U is equal to minus 5 meter. Now thereafter what else it has given? Now we have to find out V, we have to find out, and thereafter focal length we have to find out, and here it has asked. So size also we have to find. So M is equal to, that is also question mark. Now this is about given data. Now by using this data, let's we solve the numerical. Now here first radius of curvature given, radius of curvature. By using that formula, R is equal to twice of focal length. R is equal to twice of focal length. Okay, even if you want, you write small letter F only, double principal focus. Okay, now let's substitute the values in that. R how much? 3. 3 is equal to 2 into F. And now you send this side, it will be comes to denominator, that is equal to F. Now general method, 2 divide. Okay, so 2 1s are 2. Now 1 left, 0.0, 2 5s are 10. General division. Now what answer finally we got? 1.5. So F is equal to 1.5 meter. F is equal to 1.5 meter. Now F value we have got, right? And now let's we move on to F value we got. Now once if we know F value and U value, V value, we can able to find out. Now we will use mirror formula. Mirror formula. And now mirror formula is nothing but 1 by V plus 1 by U is equal to 1 by F. Here either you rearrange or it may directly you substitute. Now let me do directly. So 1 by V plus 1 by U means nothing but minus 5. See here it is in bracket you written minus 5. That is equal to 1 by F means how much you got? 1.5. Now values we have substituted. Now let's we move on to simplification. Now 1 by V, this is plus into minus, minus 1 by 5 is equal to 1 by 1.5. 1 by 1.5. Now again 1 by V as it is we will write, and now this minus 1 by 5, let's we will send that side. 1 by 1.5 plus 1 by 5, it will become plus 1 by 5, and now 1 by V is equal to, so here you can write it is nothing but 10 by 15 by cancelling decimal point. After decimal point 1 digit is there, so 10 you add to numerator plus 1 by 5. Now 1 by V is equal to, now 5 and 15 you take LCM. So 5 1s are 5 3s are, okay, 5 1s are 5 3s are 15. Now 5 1s are 5, 5 3s are 15 will be the LCM. 15 will be the LCM. Now 15 means directly you can able to do now. So here 15 1s are, so 10 plus 3. Now what it will come here only I will write thereafter. 1 by V is equal to 13 by 15, and now reciprocal. Okay, V is equal to 15 by 13. Majority of students are making mistake here also, don't do. Now let's move on to 13. Let's divide 13. Now here 15. 13 1s are 13. 2 left. Now 0. Again 13 1s are 13. Now 7 left. Now point already we have to. Now 0. Okay. 13. 5s are 65. Now 5 left. So such like only it goes on. Now V is equal to, now we got 1.15 meter. Now here we got focal length value and we got here. So image distance value also we have got. Now our next process is we have to find out this one we got and this one we got, and now magnification we have to find out. On the base of magnification, then we can able to write nature and size of the image. Okay, dear students, now magnification formula for mirror, M is equal to H dash by H is equal to minus V by U. And now in given data, in terms of height related, nothing is there. So you no need to use this one directly. M is equal to minus V by U, and majority of students are having confusion. See, in given data, height related something is there, then you use it. Otherwise, just directly minus V by U. Now, M is equal to V value, how much we have got? Object distance 1.15. We are already minus is there, minus 1.15 you write, divided by U value how much? It is nothing but minus 5. And now this minus get cancelled. And now M is equal to, now after decimal point 2 digits are there. After decimal point 2 digits are there. So you write 115 by cancelling the decimal point. Now here 500 you write. Got it? And now, so from 5 1s are 5 1s are and 0 0. Got it? And 5 2s are 10, and now 5 3s are 15. Now 23 by 100. Now let's be 100, 23. We will divide. Got it? Now, so point, we have to choose point, and now here 0, 100, 2 is 200. Now what left? 30. Already point we have to, so one more 0 here you take, and 3 is nothing but 300. 100 3 is 300. Now 0, 0. And the final answer we have got m is equal to 0.23. M is equal to 0.23 meter. Okay, so this is the magnification. Now our next thing is need to write nature, position, all those things by using Cartesian sign rule. And yesterday we have discussed, so nature and depends upon magnification. Magnification value, if it comes in terms of positive, then the nature of the image is nothing but virtual and erect. Virtual and erect. Okay, so nature of the image we have written. And now see here, magnification, size also. If more than 1, enlarge. Less than 1, diminish. Is equal to 1 is nothing but same size. And 0.23 is less than 1. Less than 1 means what it will come? So it is diminished. Diminished. So I hope this much if you write, that's more enough. And image distance, you see it arranged in terms of positive. Image distance nodabeku. So it arises in terms of 1.15 means positive. So position is opposite. Opposite, another side of the mirror. Okay.